Hello, Sophie, Chilli here, and part 2 of the water pumps. And for that, we'll need a pen and some paper. So we've had the water pump running now for about a week now, and I'm noticing that it's still delivering far too much water. And I've dialed it all down. I've dialed it to 1 second, so 1 hours of water time, or delivery time, or whatever the technical word is, and 16 hours of off. So it's 1 hour on and 16 hours off. And it's still delivering far too much water. So I thought this morning that I'll alter the little electronics that I've built, but to do that I need to know how much water is actually being delivered, because I'm going to try and do this scientifically like. So I'm going to measure and count the number of water drops that are dropping off the little drop holder thingies, and then work out the volume of the water that's delivered in an hour, and then I can decide if that's far too much or just right or whatever it is. At least then I've got some kind of stick in the ground, be it a wet ground at the moment, to actually go with, and then decide how we're actually going to best achieve watering without actually having the plants float out of the balcony into the house. Alright then. Right, the first thing to do is to get an idea of how much water is being delivered in a set period of time, basically. So what I'll do, I will now video the drips for, say, 30 seconds, count the number of drips, and then we'll know then how many drips per 30 seconds, which is drips per, which we can then calculate drips per minute and drips per hour. And then we can Google to find out how much volume is in the average drop of water. Okay, so we now know just how many drops of water per 30 seconds the little delivery system is giving. So the next thing to do is to decide on what we think is an average size drip of water and how much volume of water is in that each drip. So we have our good friend Google to sort that out for us. How much water in a drop of water? How much water on a foresight? Convert water of limits inside volume. Convert milliliters, drops of water, drops of millimeter, but to solution. My shower is leaking. How many molecules in a drop of water? How many drops of water in a gallon? Well, let's do the old school way of doing it. Everyone knows what a gallon of water looks like. That's what we got here. How many drops of water in a gallon? That's really useful. What's that that says there? It depends on the size of the drop. However, it is generally accepted that a drop of water is 0.05 milliliters for pharmaceutical applications, which means there are 20 drops of water in 1 milliliter. Excellent. Okay, so I have a pen and some paper, and I have a calculator, as you can see. So we're now going to work out just how many milliliters are actually being delivered to our plants every hour, and hence every week. And so it gives an idea of and a feel for how much water, because I know how much rough water I used to be chuck at the plants before. So let's just see how much water this delivers, and we'll see where we are. Okay, so start with some basic facts. We know there are basically 13. Can you see them? Let's start with some basic facts. So there are 13.5 drops every 30 seconds. Okay. And so that equates to 27 drops per minute. And an hour is 1620 an hour. So they're 1,200 and 1,620 drops per hour. Okay, so what else do we know? We know that there are 20 drops in 1 milliliter of water. So now we can work out is if we divide that figure by that, we get the number of milliliters that have been delivered. So it's 1620 divided by 20 equals, divided by 20, 81. 81 milliliters of water every hour. So 81 milliliters, that's roughly, oops, can you still see that? Can you still see that? So it's 81 milliliters of water. So that's roughly about ish a third to a half a cup of water every hour. Okay, so that's an hour. So now we do is a week. Okay, a week. How many hours? Hours. Okay, we know there are 7 days, or 24 hours. Times 7 equals, that's 168 hours. We all should know that. Okay, and then what do we need to do now? We need to know the pump cycle. So the pump cycle is how many hours total it's on and how many times it's off. So it's 16 off plus 1 on is 17 hours. Okay, and then what we do then to get the number of cycles and hence the amount of delivery of water, we divide that by that. So it's 168 divided by 17. Oh dear. So it's 168 divided by 17 is 9.88. 9.88 cycles. So ish 10. Okay? So 10 cycles per week. So let's just go up here. So we have 10 cycles. Okay, and it's 81 milliliters. So the total for a week is litres. So it's 0.8 of a litre every week. Now that doesn't seem a lot of water. That seems fairly actual small amount considering the amount of water that's actually in the plant, in the box. So I'll show you now. It's very wet. So that must mean then that the water that is more effectively it's soaking the soil better. So you don't need as much water by the looks of it. So even at this very, very small amount of water, less than a litre of water a week, it's actually soaking the soil to a point where it's actually coming out the bottom, it's actually lying in the tray. So I suspect this is a very efficient way of actually being very efficient with water. Very, very efficient, surprising. Because, let me just... So for every week, we have basically just under 0.8 of a litre of water being delivered to each of the window boxes, which is surprisingly not a lot of water considering I used to do one of these bottles, which is a 2 litre bottle, every other day when chilies were growing really strong. And the actual soil never was actually damp, it was always dry and dusty, except when you put water on it. So this method, using the drip method, watering method, seems to really saturate the soil very well. So I'm very surprised at that. So what I think I'll do, I think I'll keep it as it is. I'll probably just lengthen the time now to deliver maybe half the 0.8 of a litre. Maybe take it down to about half a litre of water a week and see where we are at that. Because I still think it's delivering far too much water. What's happening is that the soil's getting damp, like it should do I suppose, and the remaining little bits of water is still dripping out into the tray. I just want to show you how much water's in each of the trays, because it's quite surprising. So let's go on to the back. I'll choose this one. Can you see the water in there? Let's just have a sip. Yeah, so what's that? That's a pint. So that's half a pint. So that's 6. That's 300 millilitres of water. So it's the equivalent of what do we say? 800. So it's the equivalent of about 2/3 of a week's water there. So even with that meagre amount of water delivery to it, these plants are still getting far too much water. There's another one. Another one. Oh, that's not too bad. So we're still wasting too much water here. So that's just not helping the plants at all, being in that glass. So there we go. Now we know how much water the window boxes are actually taking now. I'm surprised how little water is actually being delivered to the plants in the boxes, and still how much water is still in the trays. So I'll reduce the amount of drips per hour for roughly half. So it's going to do roughly about 14 drips a minute, and that should be half the amount of water being delivered to my friends out there on the balcony. So I just thought you might be interested in that. What is nice and surprising is just how little water is required to keep those window boxes very, very nice and damp. Very surprising. So there you go. See you again. Bye bye.